Determine the left-sided limit and the right-sided limit and the two-sided limit as x goes to -4 of the absolute value of x squared plus 3x minus 4 over x squared plus 7x plus 12. Each of these limits involves x going to -4 of the absolute value of x squared plus 3x minus 4 over x squared plus 7x plus 12. The first thing to do is try plugging a -4 in for each of the x's. That'll give us the absolute value of -4 squared plus 3 times a -4 minus 4 all over a -4 squared plus 7 times a -4 plus 12. So we have the absolute value of -4 squared is 16, plus 3 times -4 is -12, minus 4, all over -4 squared, which is 16. A positive 7 times a -4 is a -28, and then plus 12. So the absolute value of 16 minus 12 is a 4, minus 4, over 16 minus 28 is a -12, plus 12. So we have the absolute value of 4 minus 4 is a 0, over a -12 plus 12, which is a 0. Since the limit resulted in a 0 within an absolute value, it is required to work out each side separately. So we will need to work out the limit as x approaches -4 from the left side, indicated by the negative superscript on the -4, and the limit as x approaches the -4 from the right side, indicated by the positive superscript on the -4. Of that same expression, the absolute value of x squared plus 3x minus 4 over x squared plus 7x plus 12, and the same thing on each of these one-sided limits. Let's start with the left-sided limit. The first thing to do is factor the trinomial quadratics in both the numerator and denominator. In the numerator, we have an x and an x. We need two numbers that multiply to be a -4 and add to be a +3. So it sounds like a +4 and a -1 will take care of that. In the denominator, it will be x and x, and we need two numbers that multiply to be a +12 and add to be a +7. It sounds like a +4 and a +3 will take care of that. The next thing to do is break up the absolute value of the product into the product of the absolute values. So we can separate into the absolute value of x plus 4 times the absolute value of x minus 1, all over x plus 4 and x plus 3. And now we can analyze it according to the side we're coming from. We have the left side of -4 here. The left side of -4 on the number line is more negative than -4, like -4.01. If you take a number that is less negative than -4, like -4.01, and add it to 4 in the absolute value, you will have a negative number. The absolute value ensures that what comes out of there is a positive number. If what goes in is a negative number, the absolute value will make it positive by multiplying it by another negative. So we can take away the absolute value symbols for the x plus 4 and put a negative in front of it to make the positive happen. The x minus 1 is not making a 0 in the absolute value as x goes to -4, and therefore we retain the absolute value symbols around the x minus 1. In the denominator we have the x plus 4 and we have the x plus 3. We have the 0 over 0 indeterminate form here But we can easily see the factor that's making the 0 over 0 as x goes to negative 4. It's the x plus 4, and it can cancel in the numerator and denominator. And that'll leave us with limit as x goes to negative 4 from the left side of the negative absolute value of x minus 1 over x plus 3. Now that we no longer have the 0 over 0 indeterminate form, we can try plugging a negative 4 into the remaining x's. So we'll have negative absolute value of negative 4 minus 1 all over a negative 4 plus 3. We have the negative of the absolute value of negative 4 minus 1 is a negative 5 all over a negative 4 plus 3 is a negative 1. The absolute value of negative 5 is a positive 5. There's a negative in front of that, all over negative 1. The negatives can cancel, and 5 divided by 1 is a 5. Now let's work out the right-sided limit. The same thing with this one. We will want to factor the trinomial quadratic in the numerator and the denominator. In the numerator, it will factor to x plus 4 and x minus 1, just like in the left-sided limit. And the denominator will factor to x plus 4 and x plus 3. And we can break up the absolute value of the product into the product of absolute values. And now we can analyze the limit according to the side, specifically for the absolute value that's making the 0, which is the absolute value of x plus 4. Now in this case, we are the right side of negative 4 on the number line, which is less negative than negative 4, like negative 3.99. If you add something less negative than negative 4 to a 4, like negative 3.99 plus 4, you end up with a positive number. Now the absolute value ensures that what comes out of there will be positive. If what you put in is positive, the absolute value will not change it. And that means there will be a positive out in front of it to not change the sign on it. The x minus 1 will stay in the absolute value since it's not making a 0 as x goes to negative 4. We have the 0 over 0 indeterminate form, but the factors can cancel. And we're left with the limit as x approaches negative 4 from the right side of the positive absolute value of x minus 1 over x plus 3. So we have the positive absolute value plugging the negative 4 into the remaining x's now that we no longer have the 0 over 0 indeterminate form. We will have the positive absolute value of minus 4 minus 1, which is negative 5, over negative 4 plus 3 is a negative 1. And the absolute value of negative 5 is positive 5. It will have a positive with it over negative 1. A positive over a negative will become a negative, and 5 over 1 is a 5. And there's the result of the right-sided limit. For the two-sided limit, we will compare the results of the two one-sided limits. Since they do not match each other, the two-sided limit up here will be does not exist. And there's the results of the three separate limits.